I'm going to be rattling off some examples from chapter 3.4, where the latest some latest questions in the homework are, and try to follow along. You probably could simplify most of the answers further. This is number 9, and if you suspect an answer is wrong, send me email. If a function f of x is equal to, because I'm just doing them off the top of my head. All right. To me, this looks like a power rule. So I would say the derivative of f of x is equal to the derivative of this. And this is a power rule. But it has internal structure that we need to be careful of. So this is the square root of a function is equal to, and you probably don't have to write this out if you remember that, but it's equal to a half power. And this, by the power rule, is bring down the power as a coefficient multiplied by the base. This is basically the base of this power to the -1. So that would be 1/2 minus 1 is -1/2. But we're not done because we haven't taken into account the internal structure. We just took into account the outer function. So this is as though it was just the square root of a simple variable. But know that this is not a variable. It has internal structure, and the internal structure is 1 minus 2x, and the derivative of that is 0 minus 2. So this, the internal function, 1 minus 2x, brought out a -2x into the result. Okay, 23. Y equals square root 1 plus 2e to the 3x. I see as the outermost function being the square root, and the internal functions being 1 plus 2e to the 3x. So the derivative of this is, like, by the power rule, 1/2, leaving, so now I'm taking derivative of the power as if the internal structure is not changing. So that's -1/2. Now the chain rule says that I should be taking the derivative of the internal structure there. So now, if it's getting too complicated, don't try to answer everything all at once. Just write it down. That's what you need to do next. And so let's take another line. I'm just going to put this in brackets, and I'm going to just say ditto, so I don't have to do a lot of unnecessary writing and waste your time on video. I'm just going to look at the derivative of this. The derivative of this is an addition. So by the addition rule, I should think about the derivative of 1, which is 0. And now I should think, now this is a coefficient, so I know it's not affected by the derivative. And now I need to take the derivative of e to the 3x. So the derivative of that, I'm going to just consider what the derivative of this is. Well, by the generalized exponent rule, it's e to the 3x times the derivative of its exponent, and its exponent is 3x, the derivative of 3x is 3. So if I substitute that in there, that's the derivative. It could easily use some simplifying. And I know people need work on that because Some students' algebra skills are need work. Okay, 25. Let's try 25. Y equals 5 to the negative 1 over x. This is, if I look at this, I see this as an exponential. The base is 5. The variables are in the power, so it's an exponential. And I know, actually, you know what? I'm not going to do this one. I should elaborate this in class. This is a star. We're going to do this in class on Monday. I'll put a star in the book right now. Let's go on. Let's try 27. R squared plus 1 over R. Let's try this one. I have a weird sense I did it in class. I see a square root, but the square root seems to be internal to this division here, this fraction. So I think I'm looking at a product rule. Product rule, check it out. It's the derivative of the first function, which is 1, times leave the second function alone. I'm just going to put a ditto there. Minus the first function times the derivative of the second function. The second function has a power. That's 1/2 r squared plus 1 to the negative 1/2. But by the chain rule, I need to worry about the derivative of the internal structure, and that's 2r plus 0, and that would just be 2r. All over the bottom squared. Square root squared is just the value. Number 27, let's try 29. E to the t sine 2t. The derivative of this function. Well, what do I see? I see an exponential first. Everything, this variable and this trigonometric function are internal to the exponent, so the exponent is the part I need to deal with first. It's the outermost function, and the derivative of an exponential is the exponential itself, so we're going to restate it, times the derivative of its power, and so it's the derivative of this. Now, this is in a multiplication relation, so we need the product rule. Derivative of the first function is t, that's 1, so sine 2t plus t. Now the derivative of sine is cos 2t, but it has internal structure. Instead of just t, it's 2t. The derivative of 2t is 2. You can multiply that out and simplify it. How much time do I have? I have time, I think, for one more. How about y equals cos squared? Cos x squared. This is 47. Try y prime. I see a trigonometric function with internal structure being a little power. Derivative of cos is negative sine. Leave the internal structure alone. Take the derivative of the outer function. That's cos to negative sine. Now the derivative of the internal function. Good luck on the homework.